So this is actually one of the questions that I had on my assessment yesterday. I didn't even get a chance to even look at this one. I have 15 minutes on the clock. I'm trying to get all these done within 15 minutes. Let's start looking at this one. So okay, here we go. So given an integer, return an array of subarrays where each subarray contains at least two consecutive positive integers that sum to the integer. So already I'm thinking like you can only work with numbers that are less than that number. Also, the halfway point is relevant because oh yeah, I was about to say, does the order matter? In this case, no, the order doesn't matter. It's just the numbers. So that's useful. So you already kind of set a halfway point, knowing I know like where to go. The subarrays have to add up to the given number. So for example, and I think I want to like write my test out now. So my consec sums function on 21 should return these three, because they all add up. And I notice that the 6 here is like used twice, so you cannot eliminate a number just because it's been used already. So I'm gonna console log on this just to like get that working already. All right, cool. I can certainly loop through all numbers between 1 and the midway point. I'm going to say midpoint plus 1, so in case it's a halfway. So I guess floor. So you would floor the halfway point. So let's talk about that. So iterate 1 through 1 to floor num divided by 2. Or 2, sorry. Why divide by 2? Interesting. Actually, I think that's part of the solution. So if you divide by 2, you basically get these numbers here, right? If you divide by 3, you get this. So if you take 20 divided by 2, you get 10, and then you can do your plus 1 here. If you do 20 divided by 3, 21 divided by 3 is evenly 7. So you get 7, and then you plus minus. If you do 20 divided by 4, you get 5. You can just keep iterating. So this is like, and then iterate 1, 2. So there's like 2 for loops. Over iterating 1 through floor num divided by 2 again, I guess. So this is like a big O of the number divided by 2. So meh. Sorry, this is to squared. So this is definitely not like ideal. This is also like one thing I also struggle with is like just like math, like understanding like the nuances of like trends in math and like consecutive numbers and things like that. So basic math properties, effectively, that I am just not 100% familiar with. Oh man, I'm really struggling with like the understanding of the math. I think I might just start coding this brute force one and then optimizing later. So let's just try that. Function consec sums num n is a number. So const max equals math dot seal n divided by 2. I do 4, let I equal 0, I is less than max, and then I plus plus. Also, I need to have a output. Yeah, so I need to like store output and return. Okay, so let me come down here, put some of this stuff in here, loop here. Okay, so or let j equals 0, So I would be able to actually this should start out on I. I'm gonna have my helper function here as well, a function that just is sum array. This is takes an array. I return array.reduce pre current. You start with 0. All right, so actually I want to say let j equal I, while sum of subarray is less than or less than n. We are going to append subarray push j and then j plus plus. Then we get to check if sum array is equal to n, then we know to out.push push it. Otherwise it went over and it's not worth talking about. Alright, I think this will actually work. Even though it doesn't feel very good, it's what I got. So the first one gave me a 0. So 0 is showing up when it should not be. We do see that everything else is working properly. So we need to start off with j equals I plus 1. Right? Okay. So we got it worked. Wow. I'm a little surprised actually. Let me stop the clock here. that was surprisingly frustrating to get through when I don't know why I was so apprehensive about like finishing it. I also have like 4 minutes. 4 minutes left, a little over 4 minutes, and I'm here like struggling, killing myself, and I'm like, yeah, it just works. This is definitely not optimal though, so I think I would definitely go back to optimizing it. First off, I wrote my test first, which I think I think that was useful because like you really don't know if your code works unless you're testing it. So I think writing the test first and putting like the example in the test, like that's kind of like the same thing, and I think that it's worth doing it that way. Brute force is definitely what I did. I did not optimize. I think I was struggling because I felt like I was taking so much time just figuring out the brute force method, and then walking it through. I did not do any walkthrough, did I? I don't think so. I definitely did not do it much walkthrough at all. So I definitely am struggling in my walkthrough and optimization. Coding it though, I think I'm actually like okay. Coding isn't that hard, to be honest. As long as you have a good algorithm and logic, you can just code it. It's not a big deal. So what did I struggle with? Or I should say, like, having this helper function, totally helpful. Like, super helpful. Thank goodness. One thing I could have optimized for is definitely having this sum. I could probably like, store that somewhere and not have to do it so much. Also, like, I could store the sum and then just, like, add to it. Storing the subarray and then calling this sum on it is a little excessive. What matters is, like, what j is. And once you know what j is, you can just create the array after that. This, like, temp sum equals 0 at this point. So you can just say, so instead of the sum here, you just say, hey, as long as the temp sum is less than this, then instead of pushing, I just like literally add temp sum plus j, and then you increment j. And as long as temp sum is there, then that's fine. It's a little easier. For the subarray, so if you find that temp sum is equal to less than, if temp sum is equal to n, well then you can create your array at that point using I plus 1, which is the starting point for j. So I plus 1 actually current j. Oh yeah, so this is like while let start equal I plus 1. That's the same place that j started. While start is less than the current j, which is where it stopping, which is what it stopped at. Then we just do sub array push start, and then we can just like do start plus 1, and then you can push that sub array. So I'm gonna see if this is actually the same thing. Yes, the same thing. Okay, cool. Minor optimization there. Okay, still I feel like there's something I'm missing here, because looping over each number that number of times is not efficient at all. I feel there's like some recursive thing I'm missing actually. Like if you start at 21, start at n or 21, and I'm curious actually. I'm gonna look up this problem. Maybe it exists. Mathematical, yes. So this is exactly what I'm talking about. So this this problem has been done before, of course. Looping it is definitely excessive, and I definitely did not want to do that. A naive mathematical approach, you can model the situation as n equals x plus 1 plus x plus 2. Time complexity O of n? Time complexity square root of n. Jesus Christ. Oh my goodness. I was definitely doing it. Well, it worked, but this one is, I was so happy it worked too, and now I'm like, no, that was just not good at all. So you're actually using, oh my god, so you're using properties of math to figure this thing out. And this is exactly the thing I struggle with. Okay, so I'm definitely on board with what some of these other people said. Mathematical derivation should be kept below some threshold for programming questions. Yeah, like especially if it's on a technical, like I got the darn thing to work. it worked in a crappy time complexity. I totally understand that. But like, what am I supposed to do in this situation? Like, bust out my pen and paper? Like, I'm not against that, but it's not my first. It's not like intuitive enough for me to just like say, oh, that's a I can solve that with math, and then like bust this out. Like I just spend 20 minutes just figuring this out. Anyway, I'm gonna take this as a win. I feel an easier problem if you have a understanding of like the underlying mathematical relationships that are taking place. But if you're a novice like me, I've never actually taken advanced mathematics or discrete mathematics or any of that stuff that computer science majors take. I went to school for biology, so I had to learn all this stuff on my own without having an academic background in it. So I'm definitely going to stick with my crappy big n to the 2, and hopefully once I do want to like, but I'm not trying to shirk it. Like I do want to know this stuff, but I definitely don't feel like right now with my interview coming tomorrow, I'm not going to have time to really like realistically wrap my head around all that stuff for this like one niche question. So I will delegate that to future me. Anyway, hope this has been fun and helpful. I definitely didn't think I'd be able to get this so quickly, but I'm glad I did. I think I'm getting better. And so I'm on to the next one, and I'll see you around.